So this problem has a slightly different thing that we have to look at as we do it. But we start out the same way. We're going to sketch the region, figure out what it is that we're revolving, and again, we're going to try just to figure out all the things we need. What's the inner radius minus outer radius, whatever. Okay, so y equals x here, and y equals 0 is, of course, the x-axis. And then they want x equals 2 and x equals 4. Okay, so that is going to be here and there. So they want this region here. And they want that region now rotated around the line, x equals 1. Okay, so first of all, you know what? I'm going to try to let me clean this up a little bit. If I get rid of this, I'll do a whole thing, but here, so we only need the part that we're looking at. Okay, so this line is now y equals x. And this is from 2 to 4. That looks a little bit better. I'm rotating around this line. Okay. So when I rotate this region around this line, you can see it's going to be like this. Okay. That doesn't look very good. Let's try to make it at least look more or less the same over here. And so you can see I'm going to have, oh, can't draw today. It'd be like that. Okay. And you see what I'm going to have. But now, if I draw the washers, I've clearly got a problem here. In this bottom part, we can see that the washer goes between these vertical lines. So essentially, you're going to have concentric cylinders. Whereas in the top part, the outer radius is still to the vertical line, but the inner radius is to the slanted line. So essentially, we have two different regions here. So if we want to do this with the washer method, we have to consider two different regions. So we'll call this one 1. So I'll put it in here. We'll call this one 1, and we'll call this one 2. Now, if you have watched other online videos or perhaps used some other source, you may have seen another method for finding these, which is called the shell method. That is in section 6.3. We are skipping that in our class, but this would be a great one to do with the shell method. If you do it with the shell method, you don't have to break it up into two. But since we're just doing washers, we'll still do it. It's not any harder or easier. It's just a different setup, and we are going to do it this way, but we need to break it up into two. So volume is first volume plus the second volume. Now, sort of, if I think about it, what's volume 1? As I said, it's just lines, so these are just going to be cylinders. So we can do volume 1 two ways. We can look at this and say, notice, if I look at this, this is going to be a radius. This is just a radius of 3 all the way from the line x equals 1 to x equals 4, right? Okay, so and then the other one is just a cylinder of radius 1. So you can think about this as the volume of a cylinder of radius 3 minus the volume of the cylinder of radius 1. Okay, so volume of cylinder is pi r squared h. And up, what did I forget? What's the height of that cylinder, right? This is 2, right? Because this was 2, 4, and this is the line y equals x. So this is also 2 and 4. Okay? So it would be volume of a cylinder is pi r squared h. So if I look at the volume 1 just from that geometric standpoint, no calculus involved, I have pi times 9 times 2 minus pi times 1 times 2. Right, so what the heck? 16 pi? Did I get that right? Yes. Okay. So that's just your, so you can just do, you can always do that in this situation, kind of situations where you have a simple geometry. Now, here's a sanity check. Let's say we didn't do that. Let's say we did it the calculus way, right? So let's do the calculus way. Um, I have pi times, again, remember now, okay, let's watch out. Let's watch out. Because we are going around the line x equals 1. Our washers have a thickness in dy. We are going with respect to the y, right? Our washers is progressing up in y. So it's going to be 0 to 2 dy. Now, I know this line is at x equals 4, but remember, I'm not going around the line x equals 0. I'm going around the line x equals 1, right? So r equals 3. It would be this whole distance, but we're subtracting this distance, right? So basically, what we want is this distance r. So r in this case would be 3, 4 minus 1, which would be 3. So technically, if I want to think about it that way, there'd be 4 minus 1 squared minus, and then the other one is 2. So 2 minus 1 squared dy. Okay, I don't know. So I forgot to make it black, but whatever. So what do I have here? Exactly the same thing, but this is going to be 8 times dy. So I'm going to have pi times 8y from 0 to 2. So I've got 16 pi. So either way, if I do the calculus way, or I just do it geometrically, if I remember what area of the volume of cylinder is, I get 16 pi for V1. Right. So remember, that's just that bottom part. Doesn't include the slanted bit. Now the slanted bit, this is going to be my volume 2. So I have to do a little bit more work for that one, because that one I definitely do need some calculus for. So again, if I look at what that is, it's going to go from 2 to 4. Y is going to go from 2 to 4. Now, the outer radius is still that vertical line at 4, so my radius is going to still be 4 minus 1, which is going to be 3. So I'll just put it in there. But now the inner radius, instead of just being at 2, it's going to be at the line y equals x. So the line x equals y. So thinking about that, remember when we are looking at the x coordinate. So I'm just going to go over this over here. What my inner radius is on the picture is this r right there, right? So if I want no, sorry, I didn't draw it right. Oh boy. This is r here. It goes from the axis of rotation. Okay. Now, x is going to be the thing that I originally drew by accident. Sorry about that. At this point, let's see. This is going to be r, but this whole thing is going to be x. So, and this piece is going to be 1. So r is x minus 1. Okay. But we need it in terms of y because we're integrating with respect to y. So it turns out that my curve or my slant is just y equals x. So in that case, it becomes y minus 1. So then this is just y minus 1 here, quantity squared. Okay, and now again, this integral, not too bad. I got 9 minus y squared minus 2y plus 1. So I can go ahead and evaluate that. So you always have to, when you're not going around one of the coordinate axes, you always have to figure out how to get that radius involved in there. And it's basically, I find it easier. Oh, and I forget my pi. Just to draw it and try to figure it out. Thinking about everything in terms of distances, this will help you out to figure that out. It'll be 60, and this is going to be plus 16 minus 16 minus 8/3 plus 4. So let's see what I have. 32. Okay, the 16s cancel, but then I have a minus 4. So this is going to be 28. And then I've got minus 64/3 plus 8/3. So 50. Oh, whoops, minus, right? Minus 56/3. Okay, making a common denominator will give me 28/3. Okay, but remember, I'm not done. Let's go back and see. This is just volume 2. Total volume was volume 1 plus volume 2. So I had 16 pi from the first part and 28/3 pi from the second part. And so if I put those together, heck, I get 76/3 pi, which is the complete answer to the whole thing.